We are going to do an example of regression. This is number 13 from your textbook. The pressure of a car or tire with a slow leak is given in the table of values. Use technology to investigate linear, quadratic, and exponential models for the relationship of the tire pressure and time. Describe how well each model fits the data. There's a couple of different ways you could do this. You could use a graphing calculator. There's a regression way of doing it. I find it quite lengthy. Geogebra is a free graphing software and it has everything that we need. So I've already adjusted the axes and I've already done a little bit of work here. We want to change our view to spreadsheet and input the values. So I already put the values in and now we want to plot the points. So right click, create a list of points, and it's put the points for us. What is this? Is it linear? Is it quadratic? Cubic? Exponential decay? It's a little bit hard to tell. You could guess, you could make up different models, but it actually will help us. One variable analysis. Analysis means to study something very hard, so we need to study this. These are the points that we'd like to look at. If they were the wrong points, we could select them from the table. But because the table is already selected, it popped up for us. We want to analyze these points. So let's start with the linear. Does it seem to fit the points? In some places it does, in some places it doesn't. The points really seem to be more of a curve than linear. We use this number, this r squared number, to determine whether or not it's a good fit. There's a complicated formula for this, but basically, if it had a value of 1, it would be a perfect fit. If it had a value of 0, it would be an awful fit. So the closer to 1 we are, the better. This is pretty good. 97.56%. Let's see if any other models are better. Log. It can't even figure out how to do this as a log. Polynomial. Power of 2. 99.76%. That's pretty good. Let's see if there's a better one. Is it power? It can't find a model for that. As an exponent, wow, 0.9973. Seems to fit the points quite well. The same for a growth. It can't figure out how to make this a sign. It doesn't look anything like a sine function. If we go back to the polynomial, we can also adjust the power. A power of 3 fits even better. A power of 4 fits even better. A power of 5, oh, it's almost perfect. A power of 6, it fits perfectly. But look at this, look at how the curve swings up. If you were trying to extrapolate and guess other points outside, this would not be a very good function. The points should be decreasing, and here the function swings up. But for the points, it's a good model. Anyway, it didn't ask us to look at power of 6. Let's go back to the question. It's always a good idea to reread the question. Linear, quadratic, and exponential. So on the course website, you'll find this graph. I want you to look through the different values and figure out which model gives you the best fit.